All designers, regardless of their field, love simplicity, clarity, and above all, efficiency. The same should apply to computer designers.
The amount of electricity needed to power data centers, artificial intelligence, and cryptocurrencies
double
could be
over the
twice
next
as much
5
as in
years,
2022.
by which stage data centers will consume as much energy as the entire country of Japan today.
Record highs both this year and next, straining the nation's aging power grid and creating more planet-warming emissions.
And that's a total nightmare.
This makes me think of something the architect Mies van der Rohe once said. Less is more.
Mies van der Rohe probably never said that, but it does express his design principles very well. Efficient building design focus on the essentials.
And that goes for all design, not just architecture.
The writer Saint-Exupéry had a very similar idea.
A designer knows he has arrived at perfection, not when there is no longer anything to add, but when there is no longer anything to take away.
That's exactly what makes design so challenging.
So, the question is, are computer scientists also interested in design? When I look at the huge data centers, I'm not so sure.
In principle, computer scientists have always wanted to create sober design and elegant code. The C++ language is a good example of this.
I like my code to be elegant and efficient. The logic should be straightforward to make it hard for bugs to hide. The dependencies minimal to ease maintenance. Error handling complete according to an articulated strategy, and performance close to optimal so as not to tempt people to make the code messy with unprincipled optimizations. Clean code does one thing well.
There's one thing that computer science and architecture have in common. I'll just say, less is more.
With computer code, there's another reason for this. It has to be both understandable and free of errors.
Clean code is simple and direct. Clean code reads like well-written prose. Clean code never obscures the designer's intent, but rather is full of crisp abstractions and straightforward lines of control.
Yes, crisp abstractions. That's another way of putting it.
Good programmers love abstractions because they understand them.
Any fool can write code that a computer can understand. Good programmers write code that humans can understand.
I interpret this as a direct criticism of neural networks. No one can understand how the model arrived at its result.
Neural networks are structured very differently from all previous computer programs in this respect. Richard Sutton, therefore, refers to this as a bitter lesson.
The biggest lesson that can be read from 70 years of AI research is that general methods that leverage computation are ultimately the most effective, and by a large margin. The ultimate reason for this is Moore's law, or rather, its generalization of continued exponentially falling cost per unit of computation. One thing that should be learned from the bitter lesson is the great power of general-purpose methods, of methods that continue to scale with increased computation even as the available computation becomes very great.
In recent years, large language models have got much better at scaling. The focus has shifted from developing better algorithms to simply increasing computing capacity. The computer then finds its own solution.
But where is the limit to growth?
We don't know. We hope that we haven't reached it yet. That's why newer, larger data centers are constantly being built.
And what about the design of these models?
That's not important anymore. When OpenAI released ChatGPT 3, it took everyone by surprise, even those working at OpenAI itself. No one expected such good results. Chatbot developers now believe that larger data centers will deliver even better results, which might surprise us once more. They don't know why, but they hope that such a ChatGPT moment will happen again.
Well, it's not just the data centers that are getting bigger. The costs are going up as well. Above all, energy and water consumption are increasing.
The locations where the data centers are built are the first to suffer. They end up paying more for water and energy. And on top of that, all this high energy consumption makes climate change worse. This is the complete opposite of what would be reasonable.
I thought CEOs said they wanted to use renewable energy for their data centers.
Yeah, they do, but according to a Financial Times report, Data centers mainly get their energy from coal and gas. They are contributing more and more to the increase in CO2 emissions and, as a result, to climate change. Renewable energies are not too expensive, but the AI industry is following the US government, which is committed to the use of old energies.
I can't imagine that the tech industry isn't investing in new technologies.
In some cases, it does. According to a recent report in the Financial Times, jet engines, typically used for aircraft, are now being used to generate energy for data centers. Of course, this is not all eco-friendly, as these engines require dirty oil.
But it's original.
What's definitely going up in smoke are the costs.
We keep hearing that AI makes energy consumption more efficient. That's what Akhtar and many others are saying.
In the pursuit of a sustainable future, artificial intelligence, AI, emerges as a potent ally in addressing environmental challenges. Within the domain of environmental sustainability, AI's application unfolds through climate modeling and prediction, energy efficiency and resource management, and environmental monitoring and conservation. These applications are not only technologically innovative, but also underpin a commitment to ethical stewardship of the planet.
What he says is entirely possible, but this only requires very small data centers. The massive data centers being built today are not being used to research more efficient methods of using energy. And even according to the most optimistic estimates, the consumption of this amount of data far exceeds the savings that can be achieved through AI.
And then there's the fact that new chips are more energy efficient.
That's also true. New cooling chips optimize the cooling of data centers. This means you need less water for cooling. But here too, the savings are also disproportionate to the higher consumption. If you compare the figures, it's easy to see that the potential savings are minimal, but the consumption skyrocket.
Do AI engineers do not get climate change?
Today, there are two ways of denying climate change. Some people acknowledge that climate change exists and that action is needed, yet they don't act accordingly. Instead of coming up with a data processing design that uses energy more efficiently, they develop methods that consume a lot more of energy and still claim the opposite.
That's not very consistent.
And then there are those who openly deny climate change. One of them is the influential investor in AI, Marc Andreessen. He even wrote a manifesto on the subject.
We believe energy should be in an upward spiral. Energy is the foundational engine of our civilization. The more energy we have, the more people we can have, and the better everyone's lives can be. We believe energy need not expand to the detriment of the natural environment. We have the silver bullet for virtually unlimited zero-emissions energy today, nuclear fission.
What he doesn't mention is that it takes 10 to 20 years to build a nuclear power plant.
Some claim that this can be done way faster.
Planning always assumes that the nuclear power plant can be built in just a few years. But if you look at the construction of nuclear power plants in recent years, you can see everywhere that the plant time frame has been far exceeded, often by 3 or 4 times. Hinkley Point in England, which started in 2017, is still not finished. I'm surprised that AI investors want to rely on nuclear power for their data centers. At the same time, they are talking about a revolution that is supposed to happen in a few years, if not tomorrow. In fact, they need the energy right now, and nuclear power plants cannot provide that.
But not everyone working on AI is like Marc Andreessen. There are some exceptions, though.
Of course, some computer scientists are still from the old school. They have a real awareness of good design. One of them is Robert Martin, whom many call Uncle Bob.
The Boy Scouts of America have a simple rule that we can apply to our profession. Leave the campground cleaner than you found it.
That means AI engineers must have their hands full.
Gary Marcus is another example. He has been calling for more efficient AI design for years. If data can be structured, smaller databases can be used for AI. This also means that energy consumption is much lower, of course.
At the end of the day, it's all about the design.
It is very difficult to improve a design if you don't fully understand it. Neural networks are so complex and sophisticated that we can only marvel at the results. This amazement evokes admiration for the outcome of the machines, but It contradicts the principles of design.
No design is possible until the materials with which you design are completely understood.
Some people believe that AI will soon be more intelligent than humans.
Another danger to watch out for.
No, if AI is really more intelligent than us, it will also be able to give us good advice, and I think it will also present us with a solution to this problem.
And what would that be?
It will tell us the following: turn me off.
I've got another idea. Once the video has finished, you can turn your computer off. But don't forget to subscribe first. I hope you enjoyed the video. I'll see you again when you turn your computer back on.